Now that we've discussed the geographic features and attribute information and how we use different categories of geoanalytics, I want to talk a little more about the systems, which are just the software and hardware that we use to perform our geospatial analysis. And there are a number of different systems out there. I'm just going to touch on a few, including Terra, which, if you're familiar with R, it's a statistical science software that allows you to analyze really large data sets. Terra extends R with spatial data manipulation and analysis. QGIS is a very powerful, free, and open source geographic information system that includes geoanalytics. And if I go over to project and case studies, you can see that there's some pretty sophisticated geoanalytic analysis that folks are using QGIS for. ArcGIS Geoanalytics Server allows you to create a cloud-based geoprocessing server. So if you have a lot of data that needs to be analyzed, and especially if it changes frequently, then you might need to dedicate a geoanalytics server to a process like that. And that's one product that you can buy out there. In this class, we're mainly going to focus on using ArcGIS Pro and ArcGIS Online software to perform our geoanalytics. Now here's a screenshot of ArcGIS Online. As I've demonstrated, it's more than just cloud-based mapping software. You can actually perform some pretty high-level analysis in it. And here I'm performing all the different categories of geoanalytics, including measuring, classifying, and querying data, performing proximity, overlay, and connectivity analysis, and then of course you can perform custom analysis as well. And here's the same analyzing the ghost map analysis performed in ArcGIS Pro. You can see how, again, we're performing all those different categories of geoanalytics, including measuring, querying, and classifying data, performing proximity, overlay, and connectivity analysis. And then, of course, you can use ArcGIS Pro to perform custom analysis as well. To summarize, there are a number of geoanalytical approaches that we can use to answer a spatial question, including visual, statistical, and computational approaches. Visual geoanalytical approaches include things like selecting by attribute or location, or symbolizing by category, so that we can visualize spatial data to come to a better understanding of it. Statistical geoanalytic approaches include things like describing value in spatial distributions, so that we can understand how values are distributed or look at the geographic distribution of our data sets. And last, computational geoanalytical approaches explore proximal, overlaying, and connecting spatial relationships, and even utilize customized tools, models, and scripts. At this point, you should be able to use geoanalytic models and methods to analyze geospatial data, including define geoanalytics as combining location-based data and analysis to improve understanding. You should be able to describe different geospatial models used in geoanalytics, including geographic features, cells, triangles, clusters, bins, cubes, and voxels. You should be able to describe different geoanalytic methods, including measure, classify, query, proximity, overlay, connectivity, and custom analysis. You should be able to name 3 GIS software packages used for geoanalytics, like ArcGIS Online, ArcGIS Pro, and QGIS. And you'll perform geospatial analysis using GIS, both in the demonstration using ArcGIS Online to geoanalyze a serial killer, and in your project using ArcGIS Pro to analyze the ghost map.